simplification. The only new thing is that you can't have a radical in the denominator. So you have a being divided by b inside the square root. You could go ahead and share the square root onto both of them individually. So we're going to try to not have radicals in the denominator by using this property. Okay, so here's the first example, and the directions are to simplify. So this is the only thing we know so far. Notice there's a radical in the denominator, which is what we don't want. So it looks like these guys are in this position right now, where the radical is over both of them. Let's just go ahead and put the radical over both of them. So let's just have one big radical for both of them. So you get 50 over 2, like so. And then now we could divide these, because in this case you couldn't divide them, right? So now 50 over 2 is 25. So you get the square root of 25. And this is just a chain of equal signs. So then the square root of 25 is 5. So this little property helped us. Alright, so why don't you guys go ahead and give this a shot, and then pause the video or whatever, and then I'll go over it with you. So it's just like the one I did. I just threw some numbers in front of the radicals. So let's go ahead and just treat the numbers and the radicals separately. And I noticed the radical in the bottom, which is what I don't want. So I'm going to use that property again to merge these into one radical. So then you got the 4/8 over here. And now I'm going to merge these guys into one radical. Like that. So then that becomes 7. And this becomes 1/2. So you get 1/2 times the square root of 7. And then you come over here. And then that 7's on top, right? That's square root of 7. So then you get square root of 7 over 2. Alright, so we're going to do some more stuff. Alright, so why don't you guys go ahead and try another example. I'm making you guys work today. So yeah, just go over it. I'll go over it with you. We'll do this together. Alright. So you got the numbers and the radicals again, so just treat them separately. And we're just going to use this property because it helps you out a lot. And then let's merge the radicals together. And we are merging, right? Alright, so then I wanted to do that step over here. So then this becomes 1/3. And then the radical becomes 5. Because that's what you do. That's what you get when you divide by 3 and you have 15. Okay, so then that rad 5's on top, right? So you get rad 5 over 3, and that's it. Okay. So now we got variables and numbers in there, but we're just gonna still simplify and just do the what we're used to. Alright, so we got a radical in the bottom, which is what we don't want. So let's go ahead and merge these radicals using that property. So we get a big radical, and then we get a 2x on the bottom. Then we get the same stuff. But it's all under one radical now, so we could like divide and stuff, because we couldn't do that before. It's the whole point of using this property. So then now 2 goes into 16 8 times, and then 2 goes into 2 just 1 time. So that's what this becomes. And then when you have the same base and it's division, what do you do with the exponents? You subtract them. So then it's going to be x to the 5 minus 1, which is 4. And then you notice that this is multiplication, so you could like distribute the radical over multiplication if you want. You don't have to, but you could write this as rad 81 times rad x to the 4th. Because you've learned that from the multiplication video on radicals. And and then the square root of 81 is 9, and the square root of x to the fourth is x squared. And there you have it. So I assume you did all that. Now, I'm going to merge the radical into 1, first of all. Get this huge radical, and then I get 16x to the 7th, y to the 4th, and then there's a y down here, and an x down here, and a 2. So they're all under the same radical now. So this will be 8. Same base, exponent subtract, so 7 minus 1 is 6. And then this guy got a 1 exponent, so same base, exponent subtract. So you get 3, 4 minus 1 is 3. And then you could distribute the radical over every term if you'd like, if that makes it better. So then, this will be x to the third, and this will that, okay, so now we have a problem because with these, you divide the exponent on the variable by the index, but it doesn't go in evenly, so you just peel off the power. So inside the radical, I'm going to rewrite this 8 as 2 times 4. And then y to the third, I'm going to peel 1 power off, so it's y to the second times y to the first, like that. So what's going to come out of here is that 4 and that y squared. So this is going to come out as a 2, and that's going to come out as a y. So then I get 2x cubed y square root of whatever is left, which was a y and a 2. So that's my final answer. 2x cubed y inside the radical times inside the radical 2y. Okay, so now we're going to go ahead and rationalize the denominator. So here's a case where you would rationalize the denominator. Let's say we had like 5 over square root of 3, and you can't use that property that I had listed here before. You know, you can't get by in this case. The rad's in the denominator, and then we said we don't want that to happen, and there's you know, you're stuck. So then we're going to go ahead and use this technique called rationalizing the denominator. Can't even talk. So before we rationalize the denominator, let's just go over some square root properties. So like if you had rad 2 times rad 2, you would get rad 4, right? And rad 4 breaks down to 2, right? Same thing as if you had like rad 5 times rad 5, you would get the square root of 25, and that turns out to be 5. So I just wanted to bring back those properties of radicals. Notice when you're multiplying two radicals together and their insides are the same, you just end up getting what's on the inside. So the reason I brought that up is because the way you rationalize the denominator, well, there's two cases when you rationalize the denominator. I forgot to bring that up. There's the first case, which is like this, where you just have one radical on the bottom. And then the second case is where you have radicals on the bottom again, but they're being added or subtracted to the terms or whatever. So in this case, what you do is you multiply what's on the bottom, which is the rad 3, to the top and bottom. So whatever is sitting here, you just multiply that by the top and the bottom. And what is rad 3 divided by rad 3? That's just 1, right? So what we're doing here is it's not an illegal move, because it's like multiplying by 1, right? And you could multiply anything by 1, it wouldn't change it. So what we're doing here is really legal, and yeah, that's how you go about it. when you rationalize the denominator. So let's see what happens here. Notice we went over this property here. When you're multiplying two things, two rads with the same thing on the inside, you just end up getting the same thing. And then on the top, you just get 5 times rad 3. And this would be our answer because there's no radicals on the bottom. And we achieved that. So that's how you go about rationalizing the denominator the first way. And we're going to get into more examples. Alright, so why don't you guys go ahead and give this a shot. 10 over rad 5. We got a radical in the denominator, which is a no-no. So we're going to rationalize it. So I'm assuming you pause it and try it. So I'm just going to multiply this by what's sitting on the bottom, which is just the rad 5. So you get this, and this is like multiplying by a form of 1, which is cool. So then here you get the square root of 25, but if you already know it's going to be 5, but I'll just go ahead and write it. And then on the top, those just multiply together. Yeah, like you don't have to do this. You could just skip to noticing that that's 5. So you get 5 over 10 rad 5. So you wouldn't be done in a case like this because 10 and 5 divide and there's multiplication happening here, right? So then 5 goes into 10 2 times.